All right, so far we've been talking about querying data on demand, right? You ask for a value, you get it back. Simple. But what happens when that data is changing constantly?
I mean, think about a factory floor. Data from a pump, a sensor, it can change every single millisecond. If you try to keep up by just hammering the server with requests over and over, well, that's just not going to work. It's inefficient, it's slow, and for any app that needs to react in real time, you're already behind. So, to solve this problem, i3X has what's called a subscription model. And what's really cool about this is how it's designed. You've got one single consistent lifecycle, but it can power two totally different ways of getting your data. And that life cycle, it's a really straightforward four-step process. Once you get these four steps, you'll see exactly how to get that real-time data flowing.
Okay, here's how it works. Step 1, you create the subscription. The server gives you back a unique ID. Easy. Step 2, you register what you want to watch. You give it the element IDs for the data points you care about. Step 3, you start consuming that data, and we'll get into the two methods for that in a second. And finally, step 4, when you're all done, you just send a quick delete request to clean everything up. And this whole thing is super flexible. That registration step, it's additive. What that means is you can add more elements to your subscription later on, or even remove some, all without having to tear the whole thing down and start over. Pretty neat.
All right, let's dive into that first delivery mode, streaming. This one uses a really cool web standard called Server Sent Events, or SSE for short. The whole idea is that the server pushes data to you the very instant it changes.
Getting the stream started couldn't be easier. Seriously, it's just a single GET request to the stream endpoint with your subscription ID. That's it. The server then just holds that connection open, and it's ready to start pushing data your way. So the second a value changes on the server, bam, it sends a message right down that open pipe. And if you look at the payload, it should look really familiar. It's that exact same value, quality, timestamp structure we've seen before. Right here, we can see the motor RPM is sitting at 1750. And then a second later, there's another one. See, the RPM just ticked up to 1755. This is what we're talking about, a continuous, super low latency stream of updates. It's absolutely perfect for something like a live dashboard. Now, there is a really important trade-off you have to understand with SSE. It gives you what's called at most once delivery. The server does its job. It pushes every single change as it happens. But if your connection hiccups and drops, any messages that were sent during that outage, they're just gone forever. Okay, so what if you can't afford to lose a single update? That brings us to our second option, sync mode, which works with polling. So instead of that always-on open connection, with this method, your client actively pulls the server. You make a post request to a sync endpoint, and the server hands back an array with all the updates that it's queued up for you since the last time you checked in. And here's the really clever bit. When you make that post request, you're not just asking for new data. You're also telling the server, hey, I got the last batch you sent me. It's an acknowledgement. So if you call sync again and nothing has changed, the server knows you're up to date and just sends back an empty array. No wasted bandwidth. This whole mechanism gives you what's called exactly once delivery. The server will literally hold on to the latest value for every element until you confirm you got it. Nothing ever gets lost. The catch? The server only holds the most recent value. It's not going to buffer up all the little intermediate changes that happen between your polls. So this all leads to the big question, right? As an engineer building an app, how do you decide which one to use? Well, it really comes down to this. If you need super low latency and a single missed update isn't the end of the world, like for a live dashboard or an HMI display, you're going to want to use SSE streaming. But if you absolutely need guaranteed delivery, if every single value matters, think audit trails or control systems, then you have to go with sync polling. It's all about choosing the right tool for the job. And that, in a nutshell, is the subscription model. With this, we've really covered the core of the i3X API. We started with the data model, then we looked at how to navigate relationships, and now we know how to get real-time updates, the whole shebang. So remember the life cycle. Create, register, decide if you're going to stream or sync, and then delete when you're done. That's it. For all the nitty-gritty details and to see the full open API spec, you know where to go. Head on over to i3x.dev.